textbook doesn't do a lot of questions without giving you the graph first. But on your exam, you're going to be asked to graph things, a couple of things directly. So I am going to give you an additional example. Example 5, we'll call it. And I'm going to get you to graph y equals (3 times -1/2 x cubed). So if you get a transformations question like this, where you don't have the graph to begin with, that means you have to look at the equation and recognize from the 4 graphs that we did to begin with, or x squared, what was the original graph? What was the graph that you know? And in this one, you see the cubed. So your original graph you're going to think about is, and we'll call it our parent graph, is y equals x cubed. And since we've done that graph already, just quickly draw a quick sketch of it. You know the main points. You know the shape of it. You probably label 0, 0, 1, 1, -1, -1, maybe one more, 2, 8. So those graphs that we did at the beginning, the graph in the top left-hand corner of each of those pages, those were our main parent graphs. Then you have to say, what's happening to our parent graph? What are the transformations? We have this 3. Can you see that that 3 is outside of the function? It's going to be a vertical stretch. You're going to multiply your y values by 3. Next, we have a -1/2. Can you see that that -1/2 is inside the brackets? It's getting cubed. So that negative is going to be a horizontal reflection and a horizontal stretch. You're going to multiply your x values by negative for the reflection and 2, the reciprocal. Right? Everything inside is the reciprocal for stretches. Multiply your x value by -2. So considering that, we now say, well, I can take some of my original points. Maybe I choose 1, 1, 0, 0, and -1, -1. Draw my arrows to say those points are going to change. Above this arrow, I'm going to say I'm going to multiply my y values by 3, my x values by a -2. What happens to each of those points? 1, 1 becomes -2, 3. 0, 0 stays 0, 0. And -1, -1 would become +2, -3. Once we have those new points, I like to draw it on a separate grid so that your original graph doesn't get too busy. And we can label our new points. We're going to have a point at 0, 0. Okay? We're going to have a point at 2, -3. And we're going to have a point, oh, that one's, sorry, that's not the right place. +2, -3. And we're going to have a point at -2, +3. And on my exam, I would get an E9 error for what I just did.
You didn't put it through the exact point.
Okay, yeah, that I might have got even another error for. let's say it, all right, oh, there, it went through the point. I still get an E9 error. But thanks for pointing out my sloppiness. Appreciate it. No, I'm just kidding. I should number the graph. In other words, this is so typical, right? We normally make our scale by ones, right? So I went 2 to the right. I just made 2 ticking marks. I assumed that it went by ones. But it could have gone by 2s. It could have gone by 3s. So you need to label your scale of your graph somewhere. And probably the easiest way to label your scale is if I label this point as 2, -3, and this point as -2, 3, then it's obvious that I'm going by ones. The other thing some people do is they mark a +1 there and a +1 there so that they know that they're ones. But you need a scale on your x-axis and your y-axis. If you forget either of those scales, it's an E9 error, which is a half a mark. Even though, like, we get lazy, right? We're just like, oh, I went over 2 with 2 ticking marks. It should be 2. It should be obvious, but it's still something that needs to be labeled more clearly.